In question 3b, we have a particle moving at constant speed tracing a horizontal circle inside the surface of a smooth sphere. The center of the circle is a vertical distance of root 3 over 2 or below the center of the sphere. Okay, let's draw a diagram here. We have my particle here. We have, it's a smooth sphere. The reaction will be directed towards the center. This is the radius of the circle of motion, and it is root 3 or over 2. And actually I'll use a small r here for just the radius first, and then the big R, the reaction here. So if we work out x here, we need to start with the radius and we need the angle. So x is the square root of the diagonal squared minus the straight side squared. So this guy's going to be 3r squared over 4 if we square it, and that's just going to leave a quarter of r squared, which will be equal to just r over 2. And to get the angle, we can say the cos of A is equal to A r over 2 over r, which is 1 over 2. So A is equal to 60 degrees. So we resolve our forces. If this is my particle, I have mg. I have my reaction towards the center. My angle is inside, so in this direction I have r cos A, and in this direction I have r sine A. So we just have mg is equal to r sine A. mg is equal to r sine A. And we also have r cos A is equal to mv squared over r, or m omega squared r, but we're looking for speed here. So let's get r, and we can do that with the first one here. So mg is equal to r by root 3 over 2. 2mg over root 3 is equal to r. So on this side, 2mg over root 3 by the cos of A, which is cos of 60 is a half, is equal to mv squared over r. I can cancel my 2's. I can cancel my m's. So I'm going to get r g on top. If I cross multiply by r, I'll get r times this g over root 3 is equal to v squared. So v hopefully is the square root, or would be the square root of this guy, but I'm just checking there's a 2 in there, and I think I see what I've done. The radius is not r, it's r over 2. Just be careful. So that will go up there, 2v squared, and then we'll end up over here with the root 3. So that's where that 2 is coming from. So v is equal to the square root of rg over 2 root 3. Part C, an easy enough question. A plane lands with velocity 100 and decelerates at 5 meters a second. From the instant it touches, what's the time needed to stop? Well, v is equal to u plus at. If it's traveling at 100 and it wants to get to 0 and it's decelerating at 5 meters a second, the time taken will be 20 seconds, obviously. T is equal to 20 seconds. Well, actually, I would need to, that's not correct. It would be v, the final velocity 0 is equal to 100 minus 5t. I should really do that correctly. So t is still 20, but getting your signs correct is important. Assuming the landing velocity and deceleration don't change, can the plane land at a small airport where the runway is 800 meters long? Well, can it? Okay, let's have a look. It needs 20 seconds to stop. The acceleration is -5. We're looking for distance. and we have the initial velocity is 100. B S is equal to ut plus a half at squared. That's u is equal to 100, the initial. So S is equal to ut plus a half at squared should tell us how far it travels. U 100 by 20, 2000, plus, well, it's minus a half by 5 by 20 squared is 400. So that's 2000 minus a half of 2000, which is equal to 1000 meters. So it only has 800 to stop, therefore too short.